Checkpoint 4. The figure shows four orientations of an electric dipole in an external electric field. Rank the orientation according to the magnitude of the torque on the dipole and the potential energy of the dipole greatest first. So in the theory we studied, if we place the dipole in the uniform electric field, it will experience the torque as well as it will have the potential energy. The torque experienced by the dipole in the presence of electric field is given by the rule torque tau, which is equal to P cross E, which is equal to PE sine theta. Likewise, the potential energy U, which is equal to minus P vector dot E vector, which is equal to minus PE cosine theta. So now we have to apply this torque as well as the potential energy for these four dipoles. So you can see dipole 1 is here, dipole 2 is here, dipole 3 and dipole 4, and all these are placed in the electric field. So you can see the dark arrow marks refers to the electric field, and also the dipole angle with respect to the electric field is mentioned here as theta. So now I am going to use this formula for each and every dipole. So let's start with the first one for the torque. So here for torque tau 1, which is our first dipole, which is equal to, you can see based on the electric field, the angle is from here to here. Am I right? So that means the angle for the first dipole is mentioned theta here. So what should be this angle? So this angle is 180 minus theta. So we can write PE sine of 180 minus theta. What is sine of 180 minus theta? The sine of 180 minus theta is a sine theta. So here we have PE sine theta. Likewise, when you use the potential energy formula for this angle, we have U1, which is equal to minus PE cosine of 180 minus theta, because the same angle, I'm using the torque as well as the potential energy for the first dipole. Clear? And in the trigonometry we studied, cosine of 180 minus theta is minus cosine theta. So we will get minus PE of minus cosine theta. Clear? So minus into minus become plus. So the answer for U1 here is PE cosine theta. Now we have to find the torque as well as the potential energy for the second dipole, and the second dipole angle is theta only. So we can apply this formula directly. Therefore, torque tau 2, which is equal to PE sine theta only. We no need to go for 180 minus theta because the angle with respect to the electric field is mentioned. So likewise for the potential energy for the second dipole, which is U2, which is equal to minus PE cosine theta, because minus PE cosine theta is the formula. So better I can make a box here. So don't get confused about this. So this is the formula. I'm just applying the angle in this formula. So if you see the second dipole, the angle is exactly theta with respect to the electric field. But for the first one, this is the theta. So we need this angle. That's the reason we put 180 minus theta for the first part. Clear? Now we have to use the same thing for the third dipole. So again, we have to see the diagram and we have to come for the clockwise direction, but no issue. This is the angle theta. So what is this angle? This angle for third dipole is 180 minus theta, right? So here we have to write PE sine of 180 minus theta. So sine of 180 minus theta, which is equal to sine theta. So PE sine theta for third torque. Likewise for the potential energy U3 minus PE cosine of same angle, which is 180 minus theta. So cosine of 180 minus theta is minus cosine theta. So minus of PE of minus of cosine theta, which is equal to PE cosine theta. Now we have to come for the last dipole and we have to find the torque and its respective potential energy. So for the fourth dipole, this angle is theta. So we can apply this theta directly. So here the angle is PE of sine theta, and likewise for the potential energy U4, which is equal to minus PE of cosine theta. Now you can see we have to give the answer from the greatest. So let's we first consider torque. You can see the torque tau 1, tau 2, tau 3, tau 4. We got the same answer. So for the torque, we can write tau 1 equal to tau 2, which is equal to tau 3, which is equal to tau 3. That means all the torque, this is tau 4. Okay. So all the torque for the dipole will be the same. But when you come for the potential energy, you can see both two potential energy has the positive and two will have the negative. So here U1 and U2 has the positive value. So we can write U1 which is equal to U3 which has the greatest value, which is the positive value, and U2 and U4 are negative. So we can write U2 which is equal to U4. So this is the answer for potential energy. Clear? So this is the answer for the checkpoint, the last checkpoint 4. That's it. Thank you.